Welcome back. Let's move on to our next section here. So this part we're talking about this move called composition, where you're basically coming up with this idea that X is a variable that could stand for anything. It's basically just a big blank spot. So if I were to rewrite this as my function, I could also rewrite this as everywhere there was an X, I could put a blank, and then we could evaluate that function at different inputs. So we could plug whatever we want in for this blank, but then that's the same stuff we'd have to plug into these blanks, or at least equivalent things. So let's take a look at an example where we do this. So he already put the blanks in there, and we're supposed to evaluate the function at different values. So what is f of 1? So I would rewrite this thing. F of 1 would be 2 times the quantity of 1 squared plus 1 over the square root of 1 plus 1. So everywhere there I had a parenthesis, I plugged in a 1. Now I could clean this thing up. That's 1 squared is 1, times 2 is 2, 2 plus 1 is 3. 1 plus 1 is 2, square root. Bad news, square root on the bottom. So we would rationalize this, root 2 over root 2. And I would get a cleaned up answer of 3 root 2 over 2, because root 2 times root 2 is root 4, which is just turns it back into a 2. So what's nice about the AP test is you don't have to clean anything up. In pre-calculus, I was big on cleaning things up because I was trying to teach you these skills. Now that you already know those skills, you don't always have to do them. We kind of assume that you already know how to clean things up. So if you left your answer like this on a test, that'd be fine. If you cleaned it up and you cleaned it up wrong, you actually would lose like half the points. It's not like you just lose a little bit. You'd lose a ton of points. So clean up at your own risk. Okay, f of negative 1. Let's have you try this one. Pause. Give it a whirl. All right, let's see how you did. 2 times negative 1 squared plus negative 1 over square root of negative 1 plus 1. Uh-oh, game over. What's negative 1 plus 1? 0. What's the square root of 0? 0. And what's divided by 0? Undefined. So I don't even need to clean this one up at all. I know that thing is going to be undefined if I try to evaluate it. Pause again. Try the next one. Okay, let's see how far you got. We got to the hopefully 2. X plus 2 squared. X plus 2 over. X plus 2 plus 1 underneath a square root. Now you would try to expand this as best you could. This is the big part. Eventually you're going to want to be able to expand this in your head. You might not be there yet. I get it. But eventually you're going to want to be able to expand that in your head. So let's practice how to expand this. So this is x plus 2 squared really means x plus 2 times x plus 2. Then you would distribute x squared plus 2x plus another 2x plus 4, which then would be x squared plus 4x plus 4. So I want you to get to the spot where you can just see this. So if I was doing this problem, I would say, okay, that's x plus 2 times x plus 2. So that's x squared plus 2x, which is 4x, then plus 4. But we also need to distribute the 2 to this chunk. So I'm going to do that at the same time. So now I'm going to have 2x squared plus 8x plus 8 plus, and now I don't need these parentheses anymore because there's just a 1 in front of them. So when I distribute, I'd get a 1. And then I can clean this up as well. X plus 2 plus 1 is x plus 3, but it's still under a root. We can clean up a little bit more. 2x squareds, 8x and another x is 9x. Well, where did I mess up? I didn't mess up. 8x plus 1x is 9x. 8 plus 2 is 10 over x plus 3. This is another one of those weird situations where, yeah, there's a root on the bottom, but no mathematician would ever bother to clean that up. I mean, we could. It would look like this. It would be 2x squared plus 9x plus 10 times the root of x plus 3 over x plus 3. I mean, it might be different if this was factorable 20, that makes, oh, this is factorable, but either way, it's not going to, neither of the factors are going to make an x plus 3 to cancel that out, right? 2x, x, 2, 5, plus, yeah, that's not going to cancel anyway, so I wouldn't clean that up. I'd just leave it at that spot. Pause, try the next two. Let's see if you do the next two. All right, let's see how you did on the first one. I thought this one was pretty easy. 2 times e to the x squared plus, now I'm going to write parentheses when I don't need them, and there's a case where I don't need them. I don't need them here either, because I'm only substituting one thing in for my blank. Now, from here, this might be, maybe you got this far. That's pretty good. I would like you to be able to clean this up, though. E to the x to the second, so that's like x to the m to the n. Hopefully you remember that that really means x to the m times n. So I would expect you to clean this up a little bit. Maybe you'd have 2e to the 2x plus e to the x over e to the x plus 1 underneath a square root. And then last, let's take a look at sine of x minus 4, sine of the quantity x minus 4. So that would be 2 times the quantity sine of x minus 4 squared plus sine, oh, I didn't need parentheses there, but I put them, over sine of x minus 4 plus 1. The only thing I would do to clean this up, I would take the squared that's around the whole sign and I would put it, remember that you can rewrite it just around the sign. So 2 sine squared of x minus 4 plus sine of x minus 4 over sine of x minus 4 plus 1. All right, so hopefully that kind of does a quick review of this thing called composing. The details are what matters. So, I mean, one missed negative sign can ruin your whole mathematical day. So when we put one variable in for when we plug a variable expression in to x of the other function, that's what we call composition. So when I say composing functions, that's what we just did here. We composed two functions together. Let's try that again. We want to figure out what is f of x plus h minus f of x all over h. So I'm going to start off by plugging in x plus h in for my x's. So I would have 3 times the quantity x plus h squared minus 5 times the quantity x plus h plus 1. And then I'm subtracting the function. So when I subtract the functions, what's going to happen to all of the signs? Well, they're going to switch. So 3x squared is going to become negative 3x squared. Minus 5x is going to become plus 5x. Plus 1 is going to become minus 1, all over h. We're going to have you pause here and see if you can clean the rest of this up on your own. So hopefully you notice that this is going to be, again, this expansion. You want to get to a spot where you can do this in your head. So this is going to become 3 times the quantity is going to be x times x, which is x squared. Then these are the two that you want to do in your head and put together. So you're going to have x plus h times x plus h. So that's xh plus another xh, which is 2xh. And then h times h is h squared. If you can't expand this in your head, you want to get there. But if you can't yet, go over to the margin and expand it over here. Minus 5 times x plus h plus 1 minus 3x squared plus 5x minus 1 all over h. Now I'm going to distribute again. So that's 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 1 minus 3x squared plus 5x minus 1 all over h. Now, stuff should cancel at this spot. This is actually the derivative by definition you might remember from last year. 3x squared minus 3x squared cancels. Minus 5x plus 5x cancels. Plus 1 minus 1 cancels. So everything without an h canceled. I ran out of room, so I'm going to go back up here. So we have 6xh plus 3h squared minus 5h all over h. What do you notice everything has? NH. Gone, 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 gone. I traded 1 from each one. So that leaves us with 6x plus 3h minus 5. And you might remember last year that we would take then the limit of this, the limit as h approached 0 of 6x plus 3h minus 5. We would plug in 0 for h, and we would get what's called the derivative. That would be our derivative function. You might remember that from the spring. Okay, so here we are talking a little bit more about composing functions. So if I want to compose, this is now, we composed a lot of functions up to this point. Now we're going to decompose them. So we're looking for what's called the inside function or the outside function. Now I think this, once you get it, it's actually pretty easy, but it might take a little bit of time for it to click. So what this one function is, this is made up of two other functions where one is inside of the other. So who is the outside function here? Well, the way I look at it is I would say I actually kind of look for the inside function first. 4x minus 1 is inside of a square root. So that's my inside function. So I'm trying to identify what's the f of x function. And I'm trying to identify what's the g of x function, what's the inside function. So my inside function is 4x minus 1. Well, what is 4x minus 1 inside of? It is inside of 3 square root x. So let's double check this. I'm not going to box it in yet. Let's just double check and make sure this is true. So we know we're looking for h of x. Actually, no, let's do it this way. We're looking for f of g of x. So that means I would take g of x and I would plug it in for x. So that would be 3 root, and then I would plug in g of x in for that x, which would be 4x minus 1. Yep, 3, 4x minus 1, that's the same as h of x. So then these are my two functions. All right, I'm going to pause there. I just ran out of time, so we'll come back to and do the rest in another video.